Hello, my name is Khairullah, and this is my teammate Kina, and my other teammates are Hussein and Azim. And today I will be demonstrating on how to use the wine quality prediction system that is developed as part of our computational intelligence assignment. The system uses machine learning, specifically random forest classifier, to predict the quality of red wine based on its chemical properties. Then okay, so now we go to the dashboard page, which is this. Okay, so this is the dashboard page. It loads our data set, the wine qt wine qt data set, which contains 1143 total samples with 11 chemical features. Okay, so this each row. Okay, so this is the data set preview. Okay, so each row represents one wine sample. The columns are chemical properties like acidity, alcohol content, like fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, and so on. Okay. The target variable is the quality score, ranging from 3 to uh, 8, which is on here in the wine quality distribution. As you can see from the distribution, most wines score either 5 or 6, with a total count of, with 5 having the count of 483 and quality 6 having the count of 462, meaning the data set is slightly imbalanced, which is real world challenge we had to account for during training. As you can see, right, and then so the data set contains physiochemical properties of one sample. The target variable is the wine quality score, which range from 3 to 8 in this data set. The ID column is removed during model training because it is only an identifier. Okay, so next we can test out our. Okay, so this is the predict wine quality. We can enter wine chemical properties and let the trained model estimate its quality score. On how this prediction works, the system uses a trained random forest classification model. After the user enters the wine properties, the model predicts a quality score and converts it into an easy to understand category. So okay, so let's test it out. Alright, so first up we have poor wine. We have poor quality wine. Okay, so let me just type something up here. Okay, here's 6, then 1.2 citric acid. Right, citric acid is supposed to be 0. Residual sugar is supposed to be 0. Okay, then 0.12 for chlorides. Free sulfur dioxide 5. Okay, and then we go to total sulfur dioxide. Okay, 15. Let's just type this 1. Right, pH 3.9. Sulfates we do with 0.3, and alcohol we'll do 8. Okay, so with this we should get the predicted wine quality is low quality. Okay, alright, and then we'll test out the average quality. We'll adjust this again. We'll adjust the numbers again. Acidity. Okay, so this should get us average quality, acceptable wine quality. Alright, then we'll test out the properties of a good wine, of a good quality wine. Okay, so with this data, we should get good quality, good wine quality. We get a rating of 7 out of 10. And now for the to test out premium quality, I'll just adjust this again. Okay, so with this data set, we should get 8 out of 10, which is premium quality wine. Okay, so yeah, so that before. Okay, so the high quality, the point at the alcohol and versus quality chart is higher quality wines tend to have higher alcohol content, and meanwhile volatile acidity, which causes vinegar like taste, is lower in high quality wines, so better wines are less acidic. Okay, alright then, I'll hand it over to my teammate Norakina. Akina Aisyah.
Okay, so Kai, can you go into the model evaluation tab? So now I will explain the model evaluation section. So this page shows how we tested our machine learning model before using it in the system. Think of it like this. So before we trust a student to answer a real exam question, we first give them practice questions and check how many answers they got correct. So in our project, we tested two models, which is logistic regression and random forest. Random forest is it's like asking many people to vote. So each decision tree gives an opinion, and the final answer is chosen based on the majority vote. So from our result, logistic regression achieved 4.5 for 45.85% accuracy, while random forest achieved 65.5% accuracy. So because random forest gives a better result, we selected it as the final model for our wine quality prediction system. So atas balik. Yeah. So this means that when the user enters the wine properties such as alcohol, acidity, pH, and sulfates, the system uses the random forest model to predict the wine quality. So, however, the model is not perfect. Most of the wines in our data set, turn sikit to the graph. Okay. So, most of the wine in our data set have the quality scores of 5 and 6. So while very few wines have score like 3 or 8, be- so because of that, the model is better at predicting more common scores rather than at a weaker, and it's weaker at predicting rare scores. So in simple words, this page proves that we did not randomly choose a model. We compared the models and checked their performance and selected the better one. So you can scroll to the bottom part. Yeah. So moving on to the wine insight section. So this page helps us to understand the wine dataset visually. So instead of only showing numbers in a table, we use charts so that anyone can quickly understand the relationship between the wine properties and the wine quality. So the first chart shows the average alcohol content by quality. So from this chart, we can usually see that the wines with higher quality scores tend to have higher alcohol content. So that this does not mean alcohol alone decides the quality, but it shows that alcohol is an important factor for this whole system. So the second chart shows volatile acidity by quality score. So volatile acidity affects the smell and taste of the wine. So if volatile acidity is too high, the wine may taste sharp or unpleasant. So based on the data set, better quality wines usually have low volatile acidity. So if I explain it in simple terms, good wine is not only decided by only one thing, it's like a cooking. So a delicious dish does not only depend on salt, it depends on the balance of salt, sugar, spice, and other ingredients. Same with wine quality. So it depends on the alcohol acidity, pH, sulfate, sugar level, and density. So these sections also help users to see which chemical properties are related to better or lower wine quality. So at the bottom of the system also shows the feature importance, which tells us wine properties were most useful for the random forest model when making predictions. It helps us to understand not only what the model predicts, but also what factors may influence the prediction. So all of these are the feature importance, and this is the graph presented for your better understanding. That's all from us. Thank you very much.